So we're going to look at our review here. So the first one in this particular problem says solve each problem as completely as you can. So in this one, using the technique from problem 3.2, enlarge your shape from the origin by a factor of 3. So since it's centered at the origin, we can just figure out what our ordered pairs are and take and multiply by those by 3. So I already drew in a coordinate grid here for us to be able to use. So I guess I'm going to go over here and figure out what these ordered pairs are that I can take and multiply by our scale factors. So 1, 2, 3, 4, 5. So this one is 5, 1. I have 5, negative 1. I have 1, negative 1. We have 1, negative 3. And so on and so on. So I can fill those in, what those values are that I'm going to take and multiply by our scale factor. So I end up having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points that we're looking at, unless I counted that one twice, I can't remember. So I'm going to take each of those points and I'm going to multiply by 3 because our scale factor is going to be 3. So the first one, I'm just going to start from the top left and work my way around. So negative 5, 3. I'm going to take and multiply those by 3, so that's going to turn into negative 15, positive 9. So I can go ahead and graph that. So that would be based off of where I might drew my axes. It's going to be up there, and then I just keep on going. So negative 3, 3 multiplied by 3 is going to turn into negative 9, 9, and then I'm going to continue to do that for the rest of them. So negative 1, 1 is going to turn into negative 3, 3. 5, 1 will turn into 15, 3, and so on and so on. So you should be able to graph that and plot those points. So if I have all of those points plotted, I can take and connect those, and then that would be our dilatation by a scale factor of 3, because I made those points 3 times as big. And they didn't have labels on them. They didn't have A, they didn't have B, so I don't need to label them as A prime, B prime. We can just cut into the points and connect them. So we end up with something that should look like that. Again, we should have an ordered pair, or we should have a grid, since we have a grid over here, so make sure we have that. That's going to be the determining factor of where those things need to go. So don't just randomly draw this side 6, this side of 18, I guess. Make sure that you have that grid in there. So now it says redraw the enlarged shape, so I'm going to redraw this one by a assumed factor of 1.5. So essentially I'm going to cut all those points in half. So I'm not going to write out every single one of those points again, but if I look at this one, negative 3, 3, if I multiply by 1/2, that's going to be negative 1.5, 1.5. So I need to make sure I draw my grid on here again. So it's centered at 0, 0, so I have the ability to just multiply those. So negative 1/2, 1.5 is going to be there. This one went out all the way to 15 and 3, so if I cut that in half, we have 7.5 and 1.5. And then we can keep on going with the rest of those points. multiplying by 1/2. So we should end up with something that looks like that. So that was scale factor 3. We multiplied all the ordered pairs by 3 from the original. This one we're taking the zoom factor of 1/2 from the enlarged. So I'm taking all these ordered pairs. I didn't write them all out, but I'm taking all those ordered pairs. I'm multiplying by 1/2, and I can go ahead and graph those. All right, so 3, 1, 15. Germain has a triangle with sides 8, 14, and 20. Sadie and Aisha both think that they have triangles that are similar to Germain's triangles. The sides of Sadie's triangles are 2, 3.5, and 5. The sides of Aisha's triangles are 4, 10, and 16. Decide who, if anyone, has a triangle similar to Germain. So we don't have any angles to discuss here, so we only have to be able to compare sides. So if I list Germain and compare him with the first one in Sadie, so Germain is 8, 14, and 20. And then Sadie, based off of this problem, is going to have 2, 3.5, and 5. So the only way that these are possibly going to be similar is if they have the same proportions. So we can set up proportions, make sure they have the same ratio. So if I go from Germain to Sadie, the first one I have 8/2, which is 4, so I need to make sure all those other ones are 4. So if I have 14 over 3.5, we want to see if that is going to be 4. If it is, then we can say that we're good. If not, then we need to make sure that we say that it is not similar. Give me 1 second to grab my calculator. So if I have 14 divided by 3.5, that gives us 4, so we're good there. And then I also need 20 divided by 4, which we know. 20 divided by 5, which is 4. So Germain and Sadie are going to have similar triangles. We would be able to say yes by SSS. So yes by side similarity. So Germain and Sadie do work. So then I can compare the other ones. So if I compare Germain and Aisha, of those sides, so again, Germain has 8, 14, and 20. Aisha, her sides are going to be 4, 10, and 16, so 8 over 4 is 2, but if I go 14 over 10, that is not 2, it's actually 1.4, so Germain and Aisha are not going to be similar, but then I still have Sadie and Aisha to be able to compare. Some of you already may know the answer to this based off of what those were, but if I have Sadie, we have 2, 3.5, and 5, and Aisha's 4, 10, and 16, so if I look at some of those ratios, I have 2 over 4, which is 1/2. I have 3.5 over 10, which is not 1/2, so those are not going to be similar. That is going to be 0.35. So those are not similar. So the only ones that are similar to each other are Germain and Sadie because they have the same proportion. And we could have set up 2 over 8, 3.5 over 14, 5 over 20, and be 1/4. That would still work out to the same ratio. So Germain and Sadie are going to be similar to each other. So if we take a look at 3, 1, 16, super important problem for the points -2, 7, and 2, 1. So it's R and P, so we need to go ahead and make sure we plot those and label. So -2, 7. And we can label that as R, and then I have 2, 1. We can go and label that as P, and it does say that it is a line. So we're going to go ahead and connect those. So we end up with that. So we're good there. So then it says the slope, or we want to find the slope of the point so we can calculate our rise and our run. So if I look from P, I'm going to go up, which I know is a positive rise. So I'm going to go up 1, 2, 3, 4, 5, 6. And my run is going to be to the left, which we know is negative, so negative 4. So our slope rise over run is 6 over negative 4. I can go ahead and simplify that to negative 3 over 2, which is really the same thing as 3 over negative 2. So if I want to find the distance between them, the distance is this length, so I want to go ahead and use Pythagorean theorem there. So I have 4 squared plus 6 squared equals c squared. So this is a right triangle, our slope triangle, so that's our c. So I have 4 squared plus 6 squared equals c squared. So 16 plus 36 equals c squared. And then I have 52, and we can take the square root of those. So if I take the square root of 52, we end up getting 7.2111, all that stuff. So I'm going to round to the nearest tenth, so that's one spot. There's 1 0 and 10, so one spot past the decimal. If I look at the one after it, that's not going to bump up to 2. So we end up with 7.2 for that side. And then if I want to write the equation, we know we need to know the slope and the y-intercept. I have the slope of negative 3, 2, but we need to be able to figure out our y-intercept. So I need to pick one of these points up here to be our x and our y. I'm going to pick 2, 1. That's a little bit easier. So I'm plugging into y equals mx plus b. We need to be able to find our b value. So my y from the ordered pair is 1. My slope that I found is negative 3 over 2. My x value is going to be 2 and plus b. So if I go ahead and solve that, negative 3 over 2 times 2 just gives me negative 3. So I have 1 equals negative 3 plus b plus 3 plus 3. B is equal to 4. We can definitely see on that line, that's definitely where it passes. Up 3, left 2. We definitely know that that would be it. So write our equation. Y equals negative 3 halves x plus 4. So that's going to be the equation of that line up there. I suppose also for slope we could have done y2 minus y1 all over x2 minus x1. That's also a possibility. So then in D, an equation of a line that is perpendicular to RP and passing through point P. So I know point P is 2, 1. So that's going to represent our x and our y. But if it's perpendicular, we have to look at our slopes. And we know the slopes of perpendicular lines are opposite reciprocals. So if the slope of that one is negative 3 over 2, our new slope is going to have to change to 2/3. So our y, positive 2/3. Our y-intercept isn't the same. I need to be able to plug in to find that. So if I plug into y equals mx plus b, just doing this process like I did right here, I have 1 equals 2/3. My x value of 2 plus b. So 2/3 times 2 is really just 4/3. So 1 equals 4/3 plus b minus 4/3 minus 4/3. So if I take away 1 minus 4/3, I believe we end up with negative 1/3. So that is going to end up being our b value, so negative 1/3. So b is equal to negative 1/3. Now I know my b, I know our slope, so we have the ability to write our equation. So if I wrote that over here, we have y equals positive 2/3 x and negative 1/3, so minus 1/3. So there's going to be our equation that is perpendicular to P, the line above, and passes through point P. 3-1-17 for each given set of numbers. Figure out if the triangles can be made up or not. If the triangle can be made, determine if it's a right triangle. So remember, we have the triangle inequality. So if the two smaller sides, in this case 8 and 15, add up to more than the biggest side, it can be a triangle. So 8 and 15 give me 23, which is greater than 17. So yes, it is a triangle. So we're going to come back to that to see if it's a right triangle. But if I look at this one, my two smallest sides are 8 and 4, which add up to 12. It cannot be equal. It has to be greater. So this is not a triangle. So 8 and 4 and 12 cannot make it be a triangle. So if I go back to this one, we want to figure out if it's a right triangle. So we know we can find sides of right triangles using Pythagorean theorem. So we're going to plug this into Pythagorean theorem and see if it works. We know C has to be our biggest side, so that's C. A and B doesn't matter, so 8 squared plus 15 squared. Again, we want to see if this is going to work. So 8 squared 64, 15 squared 225, 17 squared 289. So if I add those two things up, we actually do end up with 289 equals 289. So because our Pythagorean theorem is true, that means that we are going to have a right triangle as well. So we can say, yes, it's a right triangle too. If it doesn't work, if we get like 125,